Okay, so in this question we have 3.664 grams of a monoprotic acid. So we often like to abbreviate a monoprotic acid as A for acid, and then we put an H on it because an acid has to be able to donate an H plus. And if it's monoprotic, mono meaning one, we just put one H on it. So we have that so many grams of that, and it's going to dissolve it in water. And then it says it took 20.27 milliliters of a 0.1578 molarity NaOH solution to neutralize the acid. This is a titration. They want us to calculate the molar mass of the acid. So a titration is where you have an some unknown substance or unknown quantity of a substance, and you neutralize it or react it fully with a known quantity of a known substance, so you can tell if it takes a specific amount of one substance to fully react the other substance, you have a balanced reaction that allows you to relate the known amount of one substance to how much of the other substance there is. So as we solve this problem, it'll illustrate one example of how a titration is used. So to do a titration, you recognize that a full reaction is occurring, and so you have to have a balanced reaction to do any calculations with the titration. So if I have a monoprotic acid and I react it with NaOH, which is what it says I'm adding to the acid to neutralize it, I should be able to predict the products. If it's a monoprotic acid, it's losing the H plus. The NaOH has an OH minus component that's a strong base, so those two are going to combine together. The OH minus will pick up the H plus from the acid. That will produce A minus, because this, which was neutral with the hydrogen, with the H plus, if it loses it, it won't be neutral anymore. And then I'll have an Na plus as well, spectator ion, that's also there floating around. So if this occurs, and I balance this reaction, it's pretty much already balanced. So I've got a coefficient of 1 here. That means that when I start with 3.664 grams of the acid, that is a certain number of moles. It doesn't mean I'm actually starting with 1 mole of the acid. I just have a 1 here because this is the relationship. It means if I did have 1 mole of acid, it would take 1 mole of NaOH to fully neutralize it or react it. But I don't know how many moles of acid I have. That's the point of the titration, to figure that out. I want to know, based on how much NaOH it took to fully neutralize the acid, how many moles of acid I have. Right? So that is the relationship. That means what I can say is, when the acid in my titration is fully neutralized, the moles of base added will be equal to the moles of acid that I started with, because of this 1-to-1 ratio. If I had a different ratio in the balanced reaction, then I would still know the relationship. It just wouldn't be a 1-to-1. It might be a 1-to-2 or a 2-to-3 or something. So that's a relationship that I can use. What I'm ultimately interested in is how many. It says what's the molar mass of the acid. So how many grams of the acid are there per mole of acid? That's molar mass. So if I have a certain amount of acid and I know how many grams are in that and how many moles are in that, I can divide that to get grams per mole or molar mass. So I put the given information in to figure that out. What I have is information about the grams of acid. 3.664 grams of acid were added. So if I know how many moles of acid I have, I put that on the bottom and divide. I don't know, it doesn't say how many moles of acid I have, but I have information about the base. It tells me that 20.27 milliliters of the base that had a concentration of 0.1578 moles per liter were needed to get it neutralized, or were needed to get enough moles of base until the moles of base were equal to acid. So if I can use this information to figure out how many moles of base were there, well, that should be equal to the moles of acid because of the 1-to-1 ratio when everything's fully reacted. And then I can use that to figure out the molar mass. So to figure out the moles of base I have, I would use this given information and use some relationships to convert it to moles. So I've got 20.27 milliliters of the basic solution. I've got molarity, which is the same as moles per liter. So that's 0.1578 moles of base per liter of solution. This is milliliters of solution. So then I just need to do 10 to the third milliliters of solution equal to 1 liter of solution, since that's a known metric relationship. So now I can cancel this, cancel this. I've got the unit I want. So I plug that in to my calculator. 20.27 times 0.1578 divided by 1,000, or 10 to the third. That gives me 0.003199 moles. So I'm limited by these two numbers to 4 sig figs, and so I've got 1, 2, 3, 4. So I should probably write that with 5 because I only want to round at the very end. Because of this relationship, that is also equal to the moles of acid. And so I can put that here to get the molar mass. Comes out to be 1.1. So I'm limited to 4 sig figs, or 6 times 10 to the third grams per mole. Questions about that? So this is something you might do in an analytical lab. You've got some unknown substance. You think it might be a specific thing, but you're not sure. But you know it's an acid, so you titrate it. You find out how many moles of it there were. You use the mass that you measure on the balance before the titration. You calculate the molar mass and say, is this the right substance? Well, if it has the right molar mass, it could be the right substance. It might be an isomer of that substance, but it's probably the right thing if it has all the right elements that add up to the right mass on the periodic table, which is what we just calculated.